Hey, Business Calc Stirrup here. Hey, so there's that one quiz online. Finish that up. I'll give you like 3 attempts, and we can do Zoom meetings later this week. Just send me an email and or it's a text message if you want to do a Zoom, and I can walk you through it. Hope all of you are doing well. Um, so this is our last unit, and this basically is the money part of our class, which is kind of cool. And so simple interest is basically this equation. A is equal to P1 plus RT. And sometimes they refer to that A as I. So that's your initial, or excuse me, I already messed up. You can't believe me. So P is your initial investment. I is how much you have at the end. R is your percentage rate. So make sure it's as a decimal. And T is time, and time is normally going to be in years. And I know you've probably seen this equation quite a few times. So let's take a look at this first example down here, how we would do this. We're going to invest $8,000 for 2 years at 9%. My gosh, if you could find a 9% bank account, dump a bunch of money into it, that's really good. How much interest will be received at the end of two-year period? So again, I'm going to go I equals P. I'll keep the I going because that's probably what we'll use throughout. So I'm going to take $8,000 and 1 plus the rate. The rate is going to be 0.09 because 9% as a decimal is 0.09 times the T, which is 2 years. And you can plug that just directly into your calculator. So 8,000 parentheses 1 plus 0.09 times 2, close parentheses. So at the end of 2 years, you'd have $9,440, which doesn't seem like much, but you're making $1,440. So if that was money that you didn't want to tie up forever, but you want to turn around, your money can make yourself some money for sure. All right, so then we have if we borrow 4,000, if 4,000 was borrowed for 39 weeks at an annual rate of 15%, how much interest is due at the end of 39 weeks? Okay, so interest is what we want to figure out. So we're going to do 4,000 borrowed at 39 weeks. So I'm going to make 39 weeks. I'm going to go 39 over 52. So then, because 52 weeks in a year, so that comes out to 0.75. So you're talking about 0.75 of a year. So you got 1 plus 15% was 0.15 times 0.75. And again, you can just plug that into your calculator. So at the end of that time, you would have 4450. Okay, so how much interest did you do? Well, what did you start with? You started with 4,000. So I'm going to go 4450 minus 4,000. So there was $450 in interest that your lender had gotten from you. Okay, then you have compound interest, and compound interest is a little bit different, and I'm actually going to go to the next page to take a look at the compound interest. So this is going to be your compound interest, where you have M. A lot of times we will call that M, will a lot of times be called N, and that's the number of times compounded. So if it's compounded monthly, that would be 12. If it's compounded quarterly, that would be 4 times a year. If it was compounded daily, that would be 365. Don't worry about that. You have leap years where we're not really dealing with that. So let's go back to our last slide and fill that in. So simple interest is just I is equal to P. I think that's what we said, P, right? Yeah. 1 plus RT, and then compound interest is going to be I equals P 1 plus R over N or M raised to the NT. Okay, and again, time is in years. Okay, so if 2,000 is invested for 3 years at 10% compounded annually, how much would the future value be? How does this differ from simple interest? Well, let's do it in both. So I'm going to plug the 2,000 in here. 1 plus R, which is 0.10, times T, which is 3. So if I do that math, I'm going to get 2,000. 1 plus 0.10 times 3. And that's going to give me 2,600. That's what it would be worth at the end. But if I use the same equation over here, where I took the 2,000 and I said 1 plus, and it's compounded annually, so that means it's once a year. So my rate is going to be 0.10 over 1 times 1 to the times, or raised to the t. So if I plug that into the calculator, 2,000, 1 plus 0.10 divided by 1, which is not really going to do anything to it, raised to the third power. So this comes out to 26.62. So you're talking about a $62 difference. Why is that happening? Is because we have a compounding amount. It's like building upon itself. It continuously grows, and actually we're not continuously growing. This is just growing at one time per year. So okay, so let's walk through that. So this one is for continuous growth. Continuous. So E is the exponential. So if I did 8,000 invested for 6 years at 8% compounded quarterly, find the future value. Okay, so quarterly means your N value or your M value and above will be how many times compounded. So we're going to go 8,000, 1 plus 0.08 compounded quarterly, 4 raised to the 4 times 6. And if we plug, that's a 6 right there. Sorry about that. If I plug that into the calculator, I get 8,000, 1 plus 0.08 divided by 4 raised to the 4 times 6, which is 24, right? So that means I'd have 12,867.50 rounded up to the nearest cent. It comes out to 0.498, but we can round that up to 0.50 because we're dealing with money. So how much interest are you talking about? So from there, I'm going to subtract 8,000 from that. So that would come out to $4,867.50 is how much money you would make. Okay. What would the amount for 12,000 after 3 years if the money was worth 6% compounded annually or semi-annually? Okay, so we're going to use this equation twice. So this equation will be used twice. So we're going to do 12,000, 1 plus 6%, 0.06 compounded annually divided by 1 raised to the 1 times 3. And this one over here, I'll do 12,000. Same exact equation. I'm just changing my M value to semi-annually, means twice a year. 0.06 divided by 2 raised to the 2 times 3. And so if we plug that into the calculator, so that comes out to 14,292.19 rounded down because of 0.192, and then 12,000, 1 plus 0.06 divided by 2 raised to the 6. So that comes out to 14,328.63 rounded to the nearest cent. So there is a difference on number times compounded. And then for an investment to have grown from 10,000 to 30,000 in 10 years, what is the interest rate? So on this one, I'm going to go 30,118 is equal to 10,000, which is my initial investment. And then I'm going to go 1 plus, I don't know what my R is, and compounded annually over 1 raised to the NT, so 1 times 10. So on this one, we can't just plug it directly into the calculator. We need to get R by itself. So I'm going to divide each side by 1,000, so 30,118 divided by 10,000 is going to come out to 3.0118 equals 1 plus R. It was R over 1, but I'll just keep it as R to the 10th. So what you want to do at that point is I then want to take the 10th root of both sides. Okay, so the 10th root is the same thing as the 1/10 power. So on your calculator, you're going to plug this in. 1/10 is 1 over 10 is the same thing as the 10th root. So I'm going to go raised to the 1 divided by 10. So that's going to give me 1.117 equals 1 plus R. Subtract 1 from both sides. So R is going to, if I subtract this one from 117, I'm going to get 0.117. So that means my rate would be 11.7%. Pretty aggressive investment. Find the future value of 1,000 invested for 20 years, compounded continuously. Okay, so continuously means I'm going to use the E. That's the exponential on the calculator. So I'm going to go 1,000 E, and then 8% is 0.08 times 20. So on your calculator, you're going 1,000 second ln. So your E is your next to your 4, but it's the second of it. And I'm going to go 0.08 times 20. So if you invested that, you would wind up with 4953.03. So that's a pretty good thing, saying, hey, I'm going to make $39 or $3,953.03 on this account. So annual percentage rate, this is basically just working backwards from the above a problem, so we can plug these. So annual percentage rate is APY. Find the annual percentage rate effective annual rate for the nominal rate of 6% compounded quarterly. Okay, so I'm going to plug in what I know. I'm going to go my APY, and I'm going to go 1 plus the rate of 0.06 compounded quarterly, so that quarterly is 4 times a year raised to the 4th minus 1. So if I do this, this is actually going to tell me what my percentage rate for the year would be. So I'm going to go in parentheses 1 plus 0.06 divided by 4, raise that to the 4th power, and then subtract 1. And so that's going to give me 0.061, which comes out to 6.1%. So notice they gave us a 6% originally, but because this is compounding a certain amount of times a year, you're actually earning more than 6%. You're getting 6.1%. Actually, 6.13% if you wanted to round it a little bit different. But that's because it's compounding more often. So your percentage rate is actually making a little bit more because it's compounded quarterly. And then what amount must be invested at 6.5% compounded continuously? So we were 25,000 in 8 years. So this one, I'm going to use the APY. Actually, I'm not going to use that one. I'm going to use the PERT equation. So how much? So I'm going to have 25,000 is my initial, or my end amount. My initial is P, I don't know, and then E raised to the 0.065. So 6.5 is a decimal, it's 0.065 at 8 years. So now we're trying to figure out how much money we'd have to put in at 25,000 at the end. So I need to go find what E to the 0.065 times 8 would be. So that's going to give me 25,000 equals P, and then P times 1.682. So I'll go 25,000 divided by 1.682. And so that would tell me that I would need 1483.63.26. If I invested that much and it was compounded continually at the end of 8 years, I'd have $25,000. So make some money. And find the annual percentage rate or effective annual rate for the nominal rate of 6% compounded continuously. So this is going to be the continuous equation I'm going to use. So I'm going to APY equals E raised to the 0.06, because 6% is that, compounded continuously. So all I have to do now, because it's continuous, that's why you're using it. So I'm going to go second E to the 0.06 and then subtract 1 from it. So that's going to give me APY equals 0.062, which as a true decimal would be 6.2%. Okay, so the next couple pages here, I want you to try and work on these, and happy to help you on any of these, but this will be all I have really for the week for us, is go through these pages, and these are from our workbook, so if you have a workbook you can do that as well, and then also this one. And I'm happy to do a Zoom with you to get us to learn. So make sure, send me a text, and I'm happy to do a Zoom meeting, and we can walk through this. So 720-273-8859 is my number, and we will just have this one lecture this week, but I want you to complete those 2 worksheets and however many Zooms you want to do. Hey, I hope you all are taking care of one another. Have a great day. Be good. Make sure you give your parents and your guardians a high five and let them know you love them. Okay? Miss you all very, very dearly. Bye-bye.